Hey guys, welcome back. In this video, we'll mainly talk about the another technology related to 5G, that is millimeter waves. But first, we will see why did we enter into this millimeter wave. So, as I was speaking in the previous video, to increase the data rate in 5G, we had gone for higher bandwidth, right? So the moment we went for higher bandwidth, what happened is that the spectrum which we were using currently for 4G or the frequency bands, if we see that, let's say this is the band somewhere around 700 megahertz till up to 3 gigahertz, for example. So in this band we see that it has been given to many operators already. There is no spectrum available here. It is completely occupied. So if you want to move to a bigger bandwidth, let's say one operator is already using 20 megahertz and immediately the other band is given to another operator for 20 megahertz or 10 megahertz or like that. But now for 5G, if we are going for let's say 100 megahertz, okay, to have this 100 megahertz in this band, there is no space. That is why we had to figure out some other band far from this, where we can see that there is so much spectrum available where we can allocate a wider bandwidth. Okay, so that is when in 5G there came the introduction of two frequency ranges, that is called as FR1 and that is then FR2. Okay, in case of 4G, there was only one frequency range, that was this one. But in FR1, we had, in 5G, we had the two frequency ranges, that is FR1, FR2. All frequencies less than 6 gigahertz come under this, and this is above 6 gigahertz. Okay, so, but as per spec, 3GPP spec, this will be usually around 24 gigahertz. That is around this one band, and around 64 gigahertz, 56 to 64 gigahertz in that range, around one more band. The exact details you can find it in the specification, but I am giving a rough numbers over here to have the picture. So this band is nothing but we are entering into millimeter waves. So now you got the clarity why we entered into the millimeter waves. So this is one major challenge when we increase the bandwidth. That's why we had to move to millimeter wave. The moment we entered into millimeter wave, we had many other challenges that I will come one by one. So in case of, so technology is done, concept with 3GPP. So in case of bandwidth, like I was telling, a lot of problems with the bandwidth increase, right? So that also I should be answering them in the upcoming videos. So like, let's say for a power consumption, and power consumption is one aspect and things like that. Okay, but with respect to millimeter wave, I will talk some more aspects related to challenges and advantages and disadvantages here. So millimeter wave, what are the challenges? So the first and foremost thing is that we are going to increase the frequency, which means the lambda is getting decreased, which implies that the path loss, okay, the equation of path loss, which is directly related to frequency. As the frequency increases, the path loss increases. So we are not in a position to transmit the signal for a longer distance. It gets attenuated much faster. Okay, so in other words, we need to pump in more power in order for it to transmit for longer distance, but that might not be so much suitable. Again, we will have a lot of energy consumption. So with the limited power itself, we should be in a position to transmit for longer distance. That is when the newer technology has been introduced, considering this challenge into mind. So that I will come in the upcoming video. So with millimeter wave, what is the advantage we are gonna get? Lambda is decreased, which means that antenna size are becoming much smaller and smaller. So we can pack more and more antennas in a very small area, and this is giving much beneficial for the introduction of one more newer technology that also I will come in the upcoming videos. Okay. Um, so I hope you got the clarity. What are the challenges with millimeter waves? Um, then with millimeter waves, what do we have? Of course, RF components. So RF components, we need to design the RF components much more stable, because we had this challenge, right, that RF components gonna become very unstable at higher frequency. But moving when we are moving to very high frequency, or in a millimeter range, then definitely we need to have more stable RF components designed. So that is another aspect. I hope all these things are clear to you. If there are more challenges or disadvantages or advantages, I will cover in the upcoming videos as and when required. Um, so with this, I think I will wind up the video. Thank you very much. Have a great day. Bye bye.